Hello and welcome back to my channel. Today we'll be discussing problem 1 from the 2012 AIME exam. Find the number of ordered pairs of positive integer solutions to mn to the equation 20m plus 12n is equal to 2012. So let's write out this equation. 20m plus 12n is equal to 2012. Notice that all of these terms share a common factor of 4. So we'll divide this equation by 4 and we will end up getting 5m plus 3n is equal to 503. Now we have a Diophantine equation. All of these terms share any common factors besides 1. So how would we proceed from here? Well, notice that this term, 5n, when you plug in a positive integer m, it can only end in 5 or 0. Now let's consider what happens if 5m ends in 0. So let me write this. Case 1, 5m ends in 0. So then 3m would have to end in 3, right? Because if it ends in 0, then the units digit of 3n would have to be 3 in order to get 503, in order for 503 to be a possibility. And the only way for 3m to end in 3 is if m ends in 1. So the possible values of m could be 1, 11, 21, 31, and so forth. Now, let's examine case 2. Case 2, 5m ends in 5. In that case, 3m would have to end in 8. Because the only possible way to get a units digit of 3, like in 503, if 5m ends in 5, is for 3m to have a units digit of 8. Otherwise, it's just simply impossible. Units digit in 8 of 8. Okay. So what values of m would lead to 3m having a units digit of 8? Well, the first example we think of is m equals 6. In that case, 3m would equal 18. Now, are there any examples for m beyond 6 where m doesn't end in 6, where 3m still ends in 18? You can try 7, 3 times 7 ends in 1. 3 times 7. 3 times 7 doesn't work. 3 times 8 doesn't work. 3 times 9 doesn't work. 3 times 10 doesn't work. So m has to be 6 or a number that ends in 6. So the possible values for m can be 6, 16, 26, 36, and so forth. Now let's combine the sequences that we determined in each of these cases into one big sequence. So the full sequence would be M can be 1, 6, 11, 16, 21, 26, 31, 36, and so forth. Now notice that this is just an arithmetic sequence with a common difference of 5. So if we find the greatest possible value of m, we can find the answer to the question, because for every possible value of m, there can only be one possible value of n. So now we can find the greatest possible value of m. And to do that, we have to look back at the equation we derived all of these cases from. 5m plus 3n is equal to 503. So we do not want 3n exceeding 503. We do not want 3m, sorry. We cannot have 3m exceeding 503. So in that case, m would be less than 3 divided by 503 is 1648, 237, 167 and 2/3. But realistically speaking, m is of the form 5 times k plus 1. If you look back here, all possible values of m are in an arithmetic sequence with a common difference of 5. So you can write any term for m as a multiple of 5 plus 1. So 5k plus 1 has to be less than 167 and 2/3. 5k must be less than 166 and 2/3. And when we divide this, we get that k is roughly less than 34. So the highest possible value of k that meets these conditions is 33. So the greatest possible value of m can be written as 5 times 33 plus 1, and that is 166. So this is the greatest possible value of m. So now if we go back to our arithmetic sequence for m, 6, 16, we know that the greatest possible value for m is 166. And once we find the number of terms that are in this sequence, we get our answer. Because for every possible value of m, there is only one corresponding value of n. So to do that, we can subtract 1 from each term in this arithmetic sequence that represents the possible values for m. And when we do that, we get this sequence: 0, 5, 10, 15, all the way up to 165. Now we can divide this entire sequence by 5. We will get 0, 1, 2, 3, 4, all the way up to 33. Because we're only trying to find the number of terms in this sequence right over here, and we're applying the same operations to every term of the sequence, this doesn't change the number of terms in the sequence. So this preserves the actual count. Now we know that in this range there are 33 terms. And here we have 1. So the total number of possible values for m is 33 plus 1, which is 34. And that is our answer.